Thank you very much. Thank you for getting up this early. I love you too, Tejas. By the way, just so you know, Tejas helped me come up with a title for the talk and also reviewed my abstract, so thank you, Tejas, for that. Well, I said I'd say it, you know. Everybody loves a good comeback story, and today for you I have a great comeback story, and that's the comeback of RPC in modern-day frameworks. And I want to start this story by going a little bit back in time to 2023, to Next.js Conf, where Sem Salikov showed this slide on the screen. I'll take a second to look at it before I move forward. Hopefully you can see why, when he showed this slide near the end of his talk, basically the entire React ecosystem went like this. Now, a lot of people went crazy because it looked like he was mixing concerns by injecting or placing SQL inside of a front-end, what looks like a front-end component, a button, an event handler for a front-end component. But that's the wrong reason to go nuts about it, because React is all about kind of mixing concerns when the concerns are actually aligned on the same purpose. So the reason that I got really excited and when I saw this was because what we see here is a front-end component, a button, invoking backend functionality, which is this SQL insert statement, as an event handler, which means that this front-end component is directly calling a backend function. And that's the magic of RPC. And not only that, but you can see how the slug value is passed from the closure or the scope of that front-end component directly into that backend function. Again, that's a part of the magic, which is RPC. And that's what I'm going to be talking about today. But first, let's start with what actually is RPC. RPC is basically, it just means a remote procedure call, which is a way of invoking a service or obtaining data from another process, even if that other process is on a different computer or across the network, using the function call paradigm, and that's the key. If we compare it to REST over HTTP, this is how it looks like. With REST, you very explicitly invoke a network function, let's say a get using fetch, passing in parameters, let's say in the URL or maybe in post params, and then you get back some response which you then explicitly need to parse. And what I didn't even show here is you probably also need to handle various network response codes. With RPC, it just looks like a function call, and it behaves like a function call, except that the code being called doesn't exist in this process on this computer, rather it exists across the network. How does this magic actually happen? I took this slide from Geek to Geek, so props to them. Basically, you've got the client-side code, this is what's labeled as 1, calling a client-side stub, kind of a placeholder that looks like the target for that function call, but in fact, instead of actually implementing the function code, what it does is it packs the parameters into some sort of a blob that it can send across the network. It then sends it and starts waiting for the response. And this is key, because in order to emulate the function call behavior, you need to wait for the response. On the other side of the network, this packet is received, it's unpacked, the actual function code is then executed, and the exact same thing happens in the other direction with the return value. Going all the way back, releasing that waiting RPC runtime, and then making it all the way back to the client in what looks like a function call return value. What are the benefits of this approach? Well, it turns out that there are quite a number. First of all, it's a very simple and familiar paradigm. Everybody who's ever programmed, I guess, is familiar with the function call type syntax. It's what we do and use all the time, so it's very natural to extend it to other scenarios as well. Another advantage is that you're working at a higher level of abstraction. There's no need for you as the person writing the code to deal with the serialization and deserialization. It's done for you by the RPC framework itself. You also don't need to explicitly deal with the network layer. Another great advantage, and I think we can all appreciate it here as people kind of, as an industry, I would say, migrating from JavaScript to TypeScript, is the type safety that's associated with RPC. The fact that it actually validates the parameters and the return value. And another great advantage is it's very symmetric. The code on the server side can be invoked by a client using this RPC mechanism, but can also be just invoked by other server-side code, just like a regular function. But so I kind of skipped ahead too quickly. Because of all these benefits, RPC became really popular when it was introduced in the 80s, and a lot of frameworks came out that supported it, including for client-server type implementations. Stuff like Corba, like DCOM, Java has the RMI mechanism. But when the web happened, RPC kind of fell by the wayside for client-server, because our clients were implemented used as web clients, and web was not appropriate for RPC. And there were several reasons for that. First of all, the legacy RPC protocols that were introduced back in the 80s and 90s were just not supported and were not compatible with the web. They were not supported by browsers, they could not go through proxies, so they just couldn't work. Another problem is that, as I explained, one of the great advantages of RPC is that it's type safe. But JavaScript itself is not type safe. So you lose one of the main advantages of RPC and one of the main reasons to actually even use it in the first place. And as I mentioned, you want to block, in order to simulate that function call-like behavior, you want to block until you get a response. But we didn't really have blocking on the web. We had the ability to have callbacks or event handlers, but that's not the same thing. It kind of breaks that paradigm. And finally, we did not have a mechanism to automatically generate the stubs on the client side or on the server side. But fortunately for all of us, the ecosystem has improved, has moved along. First of all, we got TypeScript back in 2012, so now we have type safety. Then we started getting much smarter bundlers who could statically analyze the code and could figure out and generate different code for the client and the server, which gives us the ability to automatically generate the stubs. And then in 2017, we got await, which means that we can kind of simulate blocking on asynchronous operations like communication over the network. And indeed, thanks to all of these advancements, we finally got RPC for the web. In fact, the first one was tRPC, which was introduced in 2020. And their the motto, their vision, was to easily build and consume fully type-safe APIs without schemas or code generation. And that's an interesting point, and we will see what that means. So they did leverage the type safety, and they did leverage, they did provide all the mechanisms to do the packing and unpacking automatically, but they don't actually use code generation, so they don't generate the stubs automatically for you. tRPC literally stands for TypeScript Remote Procedure Call. And very interestingly, it's a framework agnostic library, which means that you can use it with any framework. And now I think it's time for a quick demo. Don't you like a demo? So I created this very simple demo using the great Create TS Router app that TenStack have created. I highly recommend it if you want to quickly scaffold full stack application and you're not using some full stack frameworks like Next.js. So I'm simulating a database here, kinda. I've got a collection of users, As you can see, it's very simple, and I've got two functions, a get users, which returns all the users, and get users by ID, which returns the user if it finds it, and undefined otherwise. Now, I'm going to actually transform it into an RPC endpoint. And because there's no automatic stub generation, I kind of manually need to generate the stub. But fortunately, you can actually leverage Zod to do it kind of semi-automatically for you. So I import Zod, and then I create a TRPC router, and I specify that within a user's object, I have a getById method. It's a query. So it's a query. It accepts a single number value because as we saw previously, getUsersById takes a single number, which is the ID of that user. It invokes that method to get it from the database, and then it checks that it actually got a value, and if not, it throws a TRPC exception that indicates a not found value. That's how you handle such situations instead of explicitly, let's say, returning a 404 or something like that. And then, assuming you succeeded, you just return the object. That's it. Again, because there's no automatic stub generation, I also need to hook it up to the actual network layer. So I need to specify the endpoint, and I need to provide the get and post handlers. Gets are used for queries. Posts are used for mutations, which I'm not demoing here. Where it becomes really nice is on the client side. Because on the client side, in order to create the stub, all I really need to do is to do this. And as you can see, I'm using the router type, which I directly imported from the server, from the server side, which makes it very preferable to use TRPC in a monorepo. And then I just wrapped the getUserById, and here you can see that I'm literally calling on the TRPC client. I'm calling users getById in the query. And what's really cool about it is that if I delete it, I get automatic completion. Unfortunately, it's guessing too much, but you can see that it's filling in the blanks for me. And if I pass the wrong values, let's say I pass a string, I'm getting a squiggly. Hello, not hell. I'm getting a squiggly because it's the wrong type. And likewise, if I check the actual return type, I see that it's exactly the return type which I want to get, which is really awesome if you think about it. There's no dealing with explicit JSON parsing and all the shenanigans we have to deal with when getting typed values across the network. It just works. Now I'll make it ID again, save it, and just to show you that it actually works, here I didn't show that I'm actually passing value, the ID number 3, and the ID number 3 is Bob Smith. If I actually change it to, let's say, 1, it becomes John Doe. And it's so very easy to use. This is a stupid, silly demo because this mechanism is just so dang easy to use. So this is the benefit. You want boring stuff. You want the easy to use stuff. And that's one of the great advantages of RPC, that it makes transferring values and performing operations across the network so easy. Okay, back to the slides. Okay, but if we go back to the code snippet that Sam showed, we can see that it is actually much simpler than the one I showed in TRPC, because there's magic here. And the magic is this use server, because Next.js does use their bundler to automatically generate the code that I kind of created manually with the help of Zod. It does it automatically for us when we're using RPC in Next.js. And the reason that they are able to do that is because full stack frameworks like Next.js, require sophisticated bundlers. Bundlers that are able to look at the code, analyze the code, and generate different bundles for the server and for the client from the same code. So it can also look at a function call on the client side or on the server side and realize that, hey, on the server side it can be just a simple function call, but for the client side I actually need to generate the stubs, and I have the type information, so I can actually do it automatically. It uses static analysis, it does the code generation, and as I said, it can generate the stubs and the direct function calls both. Here's what it looks like. Hopefully you can actually see it. I apologize to those in the back. I got it down as small, to as large a font as I could. But let's say we have here how it looks like when it's done outside the context of a React server component, because the previous example was a React server component. Here it's for literally calling it from the client side to the server side. So I have a separate file called action.js with useServer at the top. So this increment-like functionality is actually run on the server side only and never makes it down to the client side. And on the client side, the useClient basically says that this is code that can also run on the client, and the onClick handler definitely runs on the client. So it is able to directly invoke the increment-like function and awaits on it to simulate that blocking type behavior that you get with regular function calls. But Next.js is not really unique in this, and this is why I said that RPC is making a comeback in modern front-end frameworks, because effectively a lot of them, eventually maybe all of them, now that Remix also introduced support for React Server components, basically, essentially, all of them are eventually getting RPC. So in Next.js, it's a combination of React Server components and server actions, and you have that useServer designator that tells the bundler how to behave. Solid adopted similar style syntax. In fact, Solid really tries to kind of be or look or seem like React, but do things better. It's up to you to decide if that's the case or not. But they have the concept of server functions, also designated with useServer, and they do away with some of the intentional restrictions that React Server components in React place on this type of behavior. Qwik has very powerful RPC capabilities. I don't know if Shai will be talking about that or other magic that Qwik does. You basically wrap the function that you want to access remotely in server $, and it even supports streaming, which means that instead of just returning a single response, it can be a generator function and return a sequence of values over time that the client can actually iterate over. TenStack also has server functions. There you wrap the function with create server fn. They are very much TRPC inspired in TenStack. They try to kind of look like TRPC, but again make things easier with regard to the automatic code generation. Having said all that, having spoken about how great RPC is, obviously, in tech, there are no perfect solutions. We always encounter situations in which there are limitations that we need to work around or contend with, and it's the same in the case of RPC. So one downside of RPC is that it can cause people to implement very chatty protocols. The problem is that we're used to the fact that invoking a function is really, really cheap. And the result is that we kind of assume inherently that it's the same with RPC and forget about the fact that with RPC, every function call is a round trip over the network. So we can create a protocol where we're calling a remote function to get a value and then calling another remote function to get a value and so on and so forth, instead of just combining all of these together into a single function call that maybe provides us all the information that we need in one round trip. A similar problem is that it can create network waterfalls, because again, we assume that functions are cheap and quick to use, and then we get one value and then we need to get the next value. So instead of using something like promise all, because at the end of the day, RPC in JavaScript is built over, or TypeScript is built over promises, we could use promise all to do several RPC calls in parallel. But again, we're thinking about them like functions, so we can end up calling them sequentially, ending up with network waterfalls. So that's definitely another thing to watch out for. Another thing is that it can easily generate a plurality of endpoints and duplication of code. What I mean, the mechanism is so easy and simple to use that when you need to get some value from the backend to the front end, hey, I'll just create another RPC endpoint and just call it. If I'm using Next.js, all I need to do is put in a server dollar, put in the use server, and I'm done. Server dollar again is solid. So you can end up with a plurality of endpoints and a lot of duplication of endpoints doing essentially the same thing. And that's not a good thing from a maintainability and potentially even a security point of view. And it also leads to the issue of public versus private APIs. A lot of these RPC mechanisms are not built for public APIs. They don't publicize the way in which they determine which endpoint to use, or even the protocol that they use to send the data. It's not necessarily JSON over the wire. In fact, for some of these frameworks, it isn't JSON over the wire, it's other things. So in the case of React, for example, it's kind of their VDOM over the wire type approach. So if you want to have a public API and a private API, you end up with them being distinct and separate, even if they provide the same information. And the problem with that is that then you don't actually dog food your own APIs. So if you have a public API for something and you're using, let's say, a RESTful API for that, let's say Open API or something like that, then it's probably preferable to use that for the private type usage rather than necessarily implementing an RPC endpoint for it. A lot of these frameworks don't actually give you control over the URL endpoints that you use. They just generate them automatically for you, or the methods. For example, in the case of React, I believe that they always use post, both for queries and for mutations. And that's not necessarily what you want, again, especially if you also want to use those endpoints for public APIs. So TRPC and TenStack actually do give you the ability to control which URLs you're using and what method you're using for each call. There's also a versioning problem. Now you might think, well, if I'm building a full stack application, what does versioning even mean? But it turns out that versioning is potentially an issue in this type of a scenario because some SPAs are actually pretty long-lived, which means that somebody can have your SPA open while you're upgrading your backend. And then you create a situation in which there's a versioning discrepancy between your front end and your backend. And if you've changed one of those RPC endpoints, well, now it's potentially moved to a different address, or maybe it accepts different parameters or returns a different value. And all of these RPC frameworks don't do anything for that. They will just fail. So that's certainly something to watch out for. Maybe you want to catch such errors and then reload the page in order to force the version to the current version. You need to decide what to do in this type of a scenario. And this is a really important one. It creates the illusion of runtime type safety. That's actually a general problem with TypeScript as a whole. I think Liran Tal, if you know him, he gives an excellent talk about how TypeScript creates an illusion of runtime type safety, and that's not the case, and it's certainly not the case with RPC unless it's very explicitly done. So for example, in TRPC, if you're using Zod, then Zod will actually implement runtime type checking on the values that you send. But with other frameworks, there is no such guarantee. Now, if you are writing the code, then obviously the compiler or the linter will catch those problems while you're developing. But if, for example, some malicious player is sending wrong data to your endpoint, the fact that you're using TypeScript or RPC doesn't save you and doesn't really protect you. So what are the takeaways from all of this? First of all, the first takeaway is that modern full-stack frameworks enable type-safe front-end to back-end communication using RPC. I highly encourage you to learn it, to embrace it, to understand it, and to use it. It gives a lot of power. It makes our life as developers much easier when we're sending values from the back end to the front end, or from the front end back to the back end, or when we are invoking functionality across the network. I mentioned the pitfalls. You need to be cognizant of them, be aware of them, don't forget them, and be sure to avoid the problems that they can create. If you're looking for a general purpose solution that's framework agnostic, you don't want to tie yourself to a particular framework, then TRPC is just awesome, and I highly recommend using it. As you can see, it's been around for a while. It's been around for 5 years. It's battle tested. It's widely used. It's widely supported. So it's great, but it is less appropriate in some cases. So if, for example, you've bought into Next.js, it's probably preferable to use the RPC capabilities that are built into Next.js. And that's it. Thank you.